Welcome to the solutions for the AP Physics Kinematics problem set numbers 7, 10, and 11. Let's jump right in and get started. We have a tennis player who moves in a straight line path as shown in the distance versus time graph below. Her average velocity, which is a V with a bar over the top, in the time intervals from. So we need to find her average velocities during these time intervals, given an A, B, C, and D. The first thing that we point out here is that this is a distance versus time graph. We see our distance labeled X and our time X on the Y-axis. That's the symbol for distance or displacement in AP. And our time little t is on the X-axis. For motion graphs, time will always be on the X-axis. All right. The key word that goes with average velocity when we look at a distance versus time graph is slope. So whenever we are to calculate average velocity on a distance versus time graph, position time graph, displacement time graph, all those the same thing, we need to calculate the slope of those lines. So for A, the slope, which is the average velocity, change in y over change in x. And for the interval of 0 to 1 second, our final quantity is 4. Our initial quantity is 0 on the y-axis. And for the x-axis, our final quantity is 1, and our initial quantity is 0. This, of course, is 4 over 1, which is 4 meters per second. So there's our answer for A. For B, we want 0 to 4 seconds. Now this is a little trickier because in this case we don't have a straight line from 0 to 4 seconds. So what we have to do is actually use the equation for average velocity, which would be distance divided by time. So, and it's velocity, so we want to do displacement divided by time. So where is this object after 4 meters? After 4 meters, the object is at a position of -2 meters. And how much time did it take to get there is 4 seconds. So our average velocity during that interval is -0.5 meters per second. What does the negative mean? The negative does not mean slowing down. The negative means that the object is traveling back toward the point of origin. Okay, and ask more about that in class if you're not sure what exactly what that means. For C, 1 to 5 seconds. Again, we have the same issue here. We don't have a straight line between 1 and 5 seconds. So we're going to do the formula for this, which is x over t. The displacement from 1 to 5 seconds. Let's see, we end at 0 position, and we started at a position of 4. So our average velocity, our displacement here, from 1 to 5 seconds, started out at 4 and ended up at 0, would be -4. Final minus initial. Your displacement is where you end up relative to where you started from. Okay? All right, and then our time to get there was also 4 seconds, from 1 to 5 seconds. And so -4 divided by 4 is -1 meters per second. And again, all that means is during that interval, the object ended up coming back toward, overall, coming back toward the point of origin. Okay, and lastly in D, we're asked to do from 0 to 5 seconds. Again, we're doing the same thing here because we don't have a straight line the whole way. So from 0 to 5 seconds, we have no displacement during the 5 seconds. So our average velocity is 0 meters per second. Okay? And obviously through discussion in class and any questions you have, there'll be more on that. All right, let's jump to number 10 and highlight important information as we read here. A tortoise can run with a speed of 0.10 meters per second. We're going to call that V, and we'll call that V of the tortoise. So we'll call it VT, little subscript T there. And a hare can run 20 times as fast. Well, if a hare can run 20 times as fast as the tortoise, the velocity of the hare would be 20 times 0.10, which would be 2 meters per second. In a race, they both start at the same time, but the hare stops to rest for 2 minutes. The tortoise wins by a shell, which is 20 centimeters, which is 0.20 meters, keeping everything standard. How long does the race take? And that's time t. And what is the length of the race? And we'll call that x. Okay? All right. We're going to start with a diagram to map out. We have a tortoise and a hare here ready at the starting position. And we're just going to call this blue line right here the finish line. And of course, here's the start line. And what we're going to do is, since the tortoise is in motion for the entire trip here, we're going to call that distance from beginning to end the x value. And that is, of course, the length of the race. The hare goes this far and then stops for 2 minutes. And whether or not he resumes or not, we don't know. But we do know that the tortoise wins by a shell, 0.20 meters. So the moment the tortoise crosses the finish line, the hare is 0.20 meters behind him. And so, though it's not to scale, we'll call that 0.20 meters there. This distance then is the distance the hare travels during the time of the race. Okay? So t, as defined up in A there, is the time for the tortoise. Okay? T is the time for the tortoise. All right. Here's how we do these problems. It's really important that you pay attention to this question because you're going to see this theme repeated in a couple other questions that we have. We have two objects that are in motion here, and so what we do is we're going to set up a motion equation for each object. And we're going to start with the tortoise. Okay? All right. Neither one of these, the tortoise is not accelerating, so the only motion equation that we can use is v equals x over t. It is the only motion equation that takes into account an object when it's not accelerating. We are not going to disagree that during the course of this race, at some point, we're sure that the tortoise probably accelerated, especially off the start line, but we are not given any information as far as acceleration, so we're going to just treat it as an average velocity. Subbing in what we know that the tortoise is traveling 0.10 meters per second, and that the distance it travels is x, as in the diagram, and it covers that distance in time t. What do we have here? We have an equation with two unknowns. And you learned in math class, what do you need? You need another equation with the same two unknowns. Where are we going to get that equation? We're going to get that equation from the motion equation for the hare. Let's start off with the hare's average velocity, which we'll call VH. We'll go back over here and label this T just for clarification. They're not the same V's. Is XH over TH, the time the hare travels. Okay? Subbing in what we know, 2 equals, all right, so what do we have here? Up here at our diagram, we can also establish a relationship between the distances in the question. So you can see that the distance x equals the distance traveled by the hare plus 0.20 meters, the shell of the tortoise. Okay? In addition to that, we also know that the time that the tortoise travels is the time that the hare travels plus, what did the hare do? He rested for 2 minutes. Well, 2 minutes is 120 seconds. So the time of the tortoise is the time of the hare plus the 2 minutes that he rested. Okay? Well, if we solve this equation for xh, that would be what? X minus 0.20. What we can do is we can substitute that value of xh in the numerator of our motion equation down here for the hare. So xh is the same as x minus 0.20 divided by th. And of course, th solved here would be t minus 120. And we'll substitute that value into th in the denominator down here. Okay? All right. Continuing on. We have 2 times the quantity t minus 120 equals x minus 0.20. Okay? Now, what are we going to do here? On our tortoise equation, we see that x is the same thing as 0.10 t, multiplying both sides by t. What we can do is we can take this value of x for the tortoise, substitute it into the hare equation to eliminate x as a variable. So this would be 2 times the quantity t minus 120 equals 0.10 t minus 0.20. Okay. Continuing on, distribute the 2t minus 240 equals 0.10 t minus 0.20. Put your t terms together. So subtract 0.10 t from both sides. That'll give you a 1.9 t. Add 240 to both sides in the same step. That would be 239.8. Divide both sides by 1.9, and we get 126 seconds, which to 2 digits is 130 seconds, if we were to express our final answer for our time. Now we can take this answer, so there's your answer to A, and we can sew it back up here into the tortoise equation to find how far the race is. I'll change over to red here for that. So the x value is 0.10 times the 126 seconds. Use the non-sig fig version for that calculation. And we get, of course, 12.6 meters, which to 2 digits, of course, is 13 meters. And there you go. There's your answers to A and B. All right. Okay, to wrap it up, let's go to number 11. Find the instantaneous velocities of the tennis player in the distance time graph above, and I just pasted in the same distance time graph here. Okay. All right. And here we're not doing time intervals, we're actually doing at a particular time instance of time. When you see instantaneous velocity as a distance time graph, the keyword that needs to pop into mind here is slope of tangent. So for A at 0.50 seconds, 0.50 seconds here, so it's the same as it was before. The slope of the tangent there would be the line itself, so that's 4 meters per second.